What does the negative tell you? Where is sine negative? What quadrants? The bottom quadrants. So we know we're in quadrants 3 and 4. Then we would find the reference angle. (602). Is it 601 or 602? 601. I got you close, plus or minus. So we would do the inverse of the positive number, and that is going to spit out sine is going to be 30 degrees. That sound right? He's just like, yeah, whatever you say, Baldwin. Okay, so my reference angle is 30 and 30, which means my rotation angle, it is 310 and 330. Okay. We're just going to do this in degrees, changing the domain here. All right, so it's 210 and 330. So we're not doing this question, so what this means graphically, do you remember what the sine graph looks like? They all look like that, except for tan. Okay, does it start at 0 or 1? Starts at 0. And it goes like this. Right? There's sine +1, -1. This is 180, 360, this one like 90, that's 270. There's your sine graph. Now, when I write sine of x is equal to -1/2, what they're saying is, they're saying the sine function, this thing, where does it equal? -1/2. So I'll call that -1/2. That would be a horizontal line. And where they intersect are your answers. That's what you're doing here. You're finding where the graphs intersect. So this would be 210, and this would be 330. Okay, that's actually what you're doing. You're finding where these two functions equal each other. Visually, that's when the two graphs connect. Oh, and we've restricted our domain to 0 to 360. But what do you know about the sine graph if I don't restrict the domain? It goes forever in both directions, right? So if it goes forever, what's going to happen? You're going to get more answers, right? In fact, you're going to get an infinite number of answers, okay? Because it can go forever in both directions. All of those answers are called the general solution, okay? It's all the answers over the domain of real numbers, i.e. from -infinity to +infinity. All you have to do to get the general solution is take your answers from 0 to 360 and add multiples of the period. So, all right. I'm just going to say first and second answers, and you add multiples of the period. Now, what's the period of a sine graph? Because we're doing sine here. (360°, right? It starts to repeat itself, boom, after 360 degrees. So you write n 360. Now, what is n? N-E-I. N is an integer. Who knows what an integer is? Positive or negative whole numbers, okay? So like plus minus 1, plus minus 2, plus minus 3. You have the minus because you could be going in the negative direction. And 360. So the general solution for this question up here is basically 210 and 330 plus n 360. And that will give you every single answer, because if you make n 2, you're having 720 degrees, which is, let's just say n1, you're adding 360 degrees, which gives you that answer there. That's plus 360. You add 360 to this, you get this one. If you add 360 to that, you get that one. If you had 720, you'd get the one that's out here, et cetera, et cetera. Or if you had negative ones, you get all those answers. Okay? That's all you're doing for the general solution, is you're adding multiples of the period. All right, we're going to do one practice question, and then this lesson is over. So we're going to skip to page 604, please. All right, we're going to solve this in radians. We're going to give the general solution of 2 cos x minus root 3 is equal to 0. So it looks a little different than what we've done before, but it's just like this. If I gave you this question and I said solve for x, what would you do? How would you, what steps would you do? Just tell me. What would you do with root 3? Move it over and then divide by 2, right? It's the same thing with this. I want the trig function equaling a number. I'm going to move the root 3 over and divide by 2. So I have cos of x is equal to root 3 over 2. And then it's like all the other problems we just did. Where is cosine positive? 1 and 4. Bam. I got to find my reference angle. Who can tell me the reference angle of root 3 over 2? You can do it in your calculator, or if you remember special triangles, it will be 30 degrees. Okay, because cosine is root 3. That's a 2. Is root 3 over 2. No, I thought there was something there, but you can check here. There might be some in this drawer over here, actually. So my reference angle is 30 degrees. What is my rotation angle? What have I done to get to those two spots? 30 and 330. We need it in rads. What's 30 degrees in rads? 5, 6. Was there some there? Yeah. And how many 30-degree angles are there in 330? 11. So it's just 11 pi over 6. So there's my answer in rads. They want the general solution. So what do? I take my answers and add multiples of the period. What's the period of a cosine graph? 360, but we're in rads, so we have to say 2 pi. So we just go n 2 pi, and that's the general solution. All right. First half is the same as what we've been doing. The general, you just add multiples of the period. That's it. Nope, that's it, because that represents all possible answers. All right, we're going to solve these two, but they're super quick. So, sine of x is equal to 0. When you see sine equaling 0 or 1 or negative 1, You can do the algebra, but if you know the graphs, here's a sine graph, and here's a cosine graph. Okay. Sine of x equals 0. Where on the sine graph is it equal to 0? 0 is one of them. And so right away, you can just go 0, 180, and 360. If I'm asking, so those would be in rads, 0, pi, 2 pi. If I want to know the general solution, what do I do? Multiples of the period. What's the period? There you go. So you can just go 0, pi, and 2 pi plus n2 pi. Perfectly correct answer. I'm not going to mark that wrong. Can anybody see a way to simplify that to one statement? Look at these answers. 0 pi, 2 pi. You would get 3 pi. You would get 4 pi. You would get 5 pi. They're all multiples of pi. So you could just write n pi. And that would give you all the answers as well. All right? I don't expect that you do that. If you just do this, take your answers and add n2 pi, I'm happy. If it's in rads, yeah. 0 plus n2 pi. Yeah, if it's in rads and it's a sine or cosine. What if it's a tan graph? You would add pi, right? N pi, because tan has a period of pi, right? That's all. That's the lesson. 7a, 8a, 9a, and I want to say 11. Let me make sure. Yes, 11. 11 is essentially this cos x equals 0. Yeah.